Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with the Strivers A to Z DSA course. Just in case you don't know about it, you can check it out from the link in the description. So till now I have covered up till this particular problem. Now in this video I'll be covering up the problem, find the repeating and missing number. So what does the problem state? The problem states that you'll be given an array of n integers. You'll be given an array of n integers. So let's take this example. So over here n is 6. So you're given 6 integers. Now these 6 integers will be from 1 to 6. These 6 integers will be from 1 to 6. So if I write down everything from 1 to 6, it will be 1, 2, 3, 4, 5, 6. And if you carefully see, there is 4, there is 3, there is 6, there is 2, and there is 1 that appears twice. So that is your repeating number. So the repeating number is 1. And which number doesn't appear in the array? That is 5. So the number that doesn't appear in the array is 5. So this is your missing number. So what you have to return me is the repeating number and the missing number. This is what you have to return me, and this is the question. Got it? So if this question comes up in an interview, what is the first solution that you can think of? Or the extreme nice solution that I can think of is, I know one thing for sure, all the integers are from 1 to 6 over here. That is from 1 to n. So what I will do is, I'll probably loop from 1. So if I take 1 and I check, I'll find out that 1 appears twice. So I can say that this is the repeating number. Then I'll go to 2 and I'll do a iteration through the entire array, and I'll find that 2 appears once. Then I'll check for 3 and 3 appears once. Then I'll check for 4, 4 appear once. Then I'll check for 5 and 5 appears 0 times. So 5 is my missing number. So I'll pick up every number from 1 to 6 and I'll do an iteration in the array and I'll check how many times it appears. If it appears 2 times, it is my repeating number. If it appears 0 times, it is my missing number. So this is the extreme brute force. So if I have to write the brute force code, I can say that I'll take a couple of variables, repeating and missing. And now I'll start iterating from I equal to probably 1. And then I'll go on till n. And I'll take a counter equal to 0. And I will do an iteration on the entire array. That is from 0 to n minus 1. And I'll say if the array of j is equal to I, because I is the number, and then I'll do a counter plus plus. At the end of the day, if counter is equal to 2, I will say that this number is my repeating number, which is basically I. Or else if the counter is equal to 0, that means I did not find this number. So this will be my missing number. At any moment, I find both the repeating and missing numbers. Probably you can initialize them as minus 1. At any time, if both of them are not equal to minus 1, both of them are not equal to minus 1, I can simply break out. That's it. Simple. This will be my brute force. What is the time complexity? Very simple to guess. Big O of n square. Why? Because we are running an entire n loop. Then we are iterating through the entire array for another n times. So it is n into n. Hence the time complexity is n square. Are we using any extra space? No, we are not using any extra space. So the space complexity will be big O of 1. Obviously the interviewer will not be happy with the n squared and he'll ask you to optimize it. This is when we move to the better solution. So we have to improve n square. What were we doing? We are counting, right? So whenever something like counting comes up, what is the technique that we use to optimize? We know that for sure. We use something like hashing. So over here, can we hash elements and keep a track of how many times they appear? We can. I can say something for sure that all the numbers will be from 1 to n. In this case, all the numbers will be from 1 to 6 for sure. So what I will do is, I will end up declaring an hash array. We don't need a map data structure. We can do it using an array as well. So I'll declare a hash array. And the size that I'll take is 7. Why? Because the elements are till 6. In order to accumulate 6, we need the 6th index. And in order to have the 6th index, the size has to be 7. And initially, I will initialize everything to be 0. So basically stating, none of the numbers appear till now. All of the numbers appear 0 times. Then I'll start iterating on the array. So for the first time, I have 4. Go to 4 and increment the count by 1. Next, go to 3, increment the count by 1. Next, go to 6, increment the count by 1. Next, go to 2 and increment the count by 1. Next, go to 1 and increment the count by 1. Next, go to 1 and increment the count by 1. Once you have done the iteration, what is the next step? You know the numbers are from 1 to 6. Let's start iterating from 1 to 6. 1, the count is 2. So what you will do is, you'll say 1, your count is 2, right? So you will be my repeating number. So I get the repeating number as 1. Next, I'll move to 2. 2 says my count is 1. I'm like, okay. 3 says my count is 1. 4 says my count is 1. 5 says my count is 0. So I will say, hey, the missing number is 5, and this will be my answer. So this is how I can easily implement hashing in order to solve this particular problem. So let's quickly code up this particular solution. The problem link is in the description. At first, I'll find the size of the array. Done. Next time, I will require a hash array, so I can declare that of this size and everything initialized to 0. Next, I have to iterate through the array. So this is how you can easily iterate and go to the number which is a of I and do a plus plus. That will increment it by 1. Now you need a repeating. So repeating can be -1, and you need a missing as well. So maybe missing will also be -1. Next, you can say I equal to 1, and you can go ahead till n, and over here you can say hash of I. If that's equal to 2, please go ahead and say that this is my repeating. Perfect. Else if hash of I is 0, then this is missing. Perfect. Once you have figured out both of them, something like if repeating is not equal to -1 and missing is not equal to -1, probably I can return this particular answer, or I can break. And going ahead, I need to return a list. First I have to return the repeating and then the missing. This should be the order. So return it. Once you have done this, you can go ahead and run it off. What will be the time complexity? Can I say over here I'm running for big O of n? We are, so that's a big O of n complexity. Over here we are again running for big O of n, so that's another big O of n. So can I say the overall time complexity will be nothing but, at the worst case, big O of 2n. What about the space complexity? Can I say we are using an extra space for the hash array, and this will be the time and space complexity for the better solution. Obviously, the interviewer will not be happy with the extra space that you're using, and he'll ask you to optimize this. This is when we move to the optimal solution. So this particular problem has two optimal solutions. The first of one will be using basic mathematics, while the second one will be using the XOR method. Now, the XOR method is slightly difficult, so probably you can avoid that in an interview, but I'll still be teaching you because I don't want you to cram up solutions. I'm over here to teach you problem solving. That is why I'll be teaching you the XOR method. You might not find a lot of YouTubers teaching it because it is a tough method, but I still want you to know this because I want you to learn problem solving. That is the key over here. So first, let's get ahead with the mathematics solution. So in case you want to jump over directly to the XOR solution, you can find it in the timestamps below. So for the mathematical optimal solution, what I'll do is I'll take x and y, and I'll say x to be the repeating number, and I'll say y to be the missing number. So I've just assigned a couple of variables. First thing I'll do is I will sum up all the elements. Yes, I'll sum up all the elements of the array. So probably I can call it as S. So what is the summation of all the elements? Can I say that will be 4 plus 3 plus 6 plus 2 plus 1 plus 1? I can. And then what I will do is I will also sum up all the elements from 1 to 6. So please sum up all the elements from 1 to 6. And maybe I will call it as S of n. And if you know one thing, this is very easily found. What is it? If I ask you the summation of the first n natural numbers, what is that? N into n plus 1 by 2. Remember, it's a simple formula. Summation of first n natural numbers is n into n plus 1 by 2. So what I've done is I have summed up the entire array. I have summed up the first n natural numbers. Now I will subtract them. And I'll try to get a value. Let's see what value we get. Over here we have a minus. So if I open this bracket, will I get -1, -2, -3, -4, -5, -6? I will. So plus 4 will go off with -4. Plus 3 will go off with -3. Plus 6 will go off with -6. Plus 2 will go off with -2. 1 will go off with -1. We'll be left off with 1 minus 5. We will be left off with 1 minus 5. Let's write it over here. 1 minus 5. And that will give me a value of -4. That will give me a value of -4. Let's carefully observe. What is 1? 1 is actually x, which is my repeating number. Yes. So I'm left off with x. And what is 5? 5 is my missing number, which is y. So I know one thing for sure, x minus y is what I'm left off with. Can I write this as minus 4? Yes, because I know for sure if I simply do a subtraction, the value that I will get is minus 4. Minus 4. I will not get 1 minus 5 because when you do the mathematics, you will just have minus 4. You do not know in minus 4, 1 is or minus 5. You don't know that. You will simply get minus 4 when you do a subtraction. But on observing, I can find it out that x minus y, which is repeating minus missing, is coming out to be that value minus 4. And I will take this as equation 1. I'll take this as equation 1. So probably I'll write it over here. X minus y equal to minus 4. Tell me one thing. Back in your school days, when you had an equation and you had two unknown variables, can you solve it using one equation? Obviously no, because I have two unknown variables. So I need two equations for sure. So this is why you will again go ahead to look for another equation with x and y. Let's go back again. This time I'll try to do something different. This time I'll say, okay, let's sum up the squares. I'll call it as S2. So I'll sum up the squares. 4 square plus 3 square plus 6 square plus 2 square plus 1 square plus 1 square. I've summed up all the squares. And then I'll subtract summation of first n natural numbers, like summation of first squares of n natural number, which is 1 square plus 2 square plus 3 square, something similar to the previous one, but this time in terms of square. I'll call it as probably S2n or SN2, whatever you want to call it. S2n I'll call it. Okay, what will be the value? Can I say 4 will go off with 4, 3 will go off with 3, 6 will go off with 6, 2 will go off with 2, 1 will go off with 1. What will be left? 1 square minus 1 square minus 5 square, which is minus 24. Simple maths. And what is this? 1 square, what is this? 1 is the repeating number. Can I write it as x square? What is 5? The missing number. Y square. Can I write it equal to minus 24? I can. Can I? Do you see something over here? X square minus y square. Can you split it? Yes. A square minus b square. X minus y. X plus y equal to minus 24. If you remember, you already have the value of x minus y. You already have the value of x minus y, which is minus 4. And over here, you generated a value of minus 24. The only thing that you will get is minus 24. You will not get anything else. You will just get minus 24. So how can I figure out of minus 24 that I have 1 and 5? I cannot. That is why I have to solve equations. So I have this. What's the value of x minus y? We know it. So x plus y can be written as minus 24 x minus y. What is the value of x minus y? I can just simply erase it and I can write this as minus 4. So minus and minus will go. I'll get a value as 6. So did I get the second equation? And I got something as 6. So I know one thing for sure from my observations. It's x minus y which gives me minus 4. It's x plus y which gives me 6. Can I sum it up? If I sum it up, minus y plus y goes. I get 2x. 6 minus 4, 2. And I get x as 1. And if you remember, x was assumed to be the repeating number. So I got my repeating number. Got it? Next, I have to find y. And you can just take up, x plus y was 6. You know the value of x now. So y will be 6 minus x. X's value is 1. So you get y as 5. So I got both of my numbers. And you can eventually return it. Super simple. How do you find S2n? How do you find this value? Quite simple. Summation of squares of first n natural numbers is n into n plus 1 into 2n plus 1. Simple school formula by 6. And this can easily be found out by iterating. This can easily be found out by iterating in the array. Quite simple. Let's go back and try to code it up. So since we are summing up all the numbers and we are also summing up squares, so the number might exceed the integer boundary. So please take everything in terms of long log. So first, let's take the size of the array. What is the next thing? If you remember, first thing we have to figure out is s minus s of n. And the second thing that I have to figure out is s2 like squares minus s2 n. So I know one thing for sure. What is Sn I know and what is S2n I know. Maybe I can just find it. Sn is nothing but n into n plus 1 by 2. That's something we know for sure. This is Sn. And I definitely also know S2n. And that's n into n plus 1 into 2 into n plus 1 whole divided by 6. We know this for sure. What is the first value of x minus y? This is equal to x minus y, and this can be later found out. Okay, so let's iterate now. For I and the I equal to 0, I less than n, I plus plus. I know I have to find out two values, which is log of s equal to 0. I have to also find s2 equal to 0. So can I say s will be nothing but, very simple, a of I. Quite simple. And can I say squares will be nothing but a of I into a of I. Please make sure these are integers. So it might overflow. So please convert them into long before multiplying. Please typecast them into long before multiplying. Otherwise they might overflow. Done? In order to get the first equation, can I say the first equation, which is x minus y, will be nothing but, maybe I can write it as x minus y or whatever it is. I'll write it as first. Or what should I write it as? X minus y. Cool, let's have it as val1. Val1 will be this one, s minus sn. So what is s? S minus sn. Perfect. What is val2? Now remember, val2 was nothing but, if you remember properly, this was x square minus y square. This was val2. Correct? If you just do it. So it's like s2 minus s of 2n. This was val2. And x minus y, x plus y is equal to val2. And you already had x minus y from this equal to this value, which is val1. And this will be x plus y equal to val2 by x minus y. So I know val2 will be val2 divided by, this will come over because x minus y. So this will be over here. So val2 by val1 will give you x plus 1. So you already have two values. You have val1, which is x minus y. This is x minus y. And this now is x plus y. So I just need to find my x. What will be the value of x if I have to ask you? Again, please take long. My bad. Take long, otherwise might overflow. Okay, what will be x? Can I say x will be nothing but, if you remember, let's go back. If x minus y is val1, x plus y is val2, can I write this as val1 plus val2 by 2 is equal to x, because 2x will be, this will cut off, and 2x will be this. So can I write x as val1 plus val2 divided by 2? And can I write y as, very simple, x minus val1 will be y, coming from this equation. So can I say x minus val1 will be my y? And can I return them? Just make sure you typecast it into integer again. Otherwise, there will be a returning problem. And this will be y. Perfect. Once you've done this, please go ahead and run it. Should be running. So it does it once, and let's quickly submit it off. So if you submit it, it will be running fine. What is the time complexity? I just ran one loop, big O of n. Nothing else. Space complexity, big O of 1, just using long variables. Nothing like a lot of array size. So the time complexity of this particular one is big O of n, and the space complexity is big O of 1. I will highly recommend you to do it on your own on pen and paper. You'll get it very easily. It's just about doing it on pen and paper. If you do it, you'll understand everything, and it's very simple. So this will be the first optimal solution, and you can always give this to the interviewer and stop. You don't have to give the second one, but I'll still be teaching you the second one. So the second optimal solution will be using the XOR concept. So if you don't have an idea about bits, XOR and all of these things, you can stop over here. Probably you can watch it after some time when I will be teaching you bit manipulation. And if you have idea about bits and everything, you can definitely watch it. So XOR method is what I will be using. Again, same thing. I will say X will be my repeating and Y will be my missing number. Again, assumptions taken initially. Let's quickly do one thing. Let's XOR all the elements of the array. All the elements of the array. And along with this, let's XOR all the elements from 1 to n. In this case, 1 to 6. Perfect. So, if you know one thing, in XOR, same numbers. If you XOR 1, it will be 0. If you XOR 2, it will be 0. But if you XOR 2, it will be actually 2 because 2 and 2 will go off, but there will be still 1, 2 left. So even number of same numbers on XORing gives you 0. Okay. So can I say 4 and 4 will go off? So it will give you 0 XOR. Perfect. 3 and 3 will go off. 6 and 6 will go off. 2 and 2 will go off. 1 and 1 will go off. And it will be left off with 1 XOR 5. It will give you some value. Yes, it will give you some value. And if you try to find out the value, it will be 0, 0, 1, 1, 0, 1. So this is a 1 and 5. And if you try to XOR it, it will be 0, 0, 1. And the value that you will get is 4. So the XOR of 1 XOR 5 is 4. And I assumed 1 to be the X because 1 is the repeating number. And 5 is the missing number. So I can write it as X XOR Y equal to 4. I know this thing for sure. So can I say one thing for sure? I have two different numbers. And if I have two different numbers, the XOR of two different numbers will be different at 1 bit. Please hear me out carefully. Since they are two different numbers, they're bound to be different at 1 bit minimum. What do you mean by bit? This is the 0th bit position. This is the first bit position. This is the second bit position. By the way, 0 in bit manipulation is written like this. 5 in bit manipulation is written like this. And this is the 0th bit. This is the first bit. This is the second bit. So if you have two different numbers, they're bound to be different at 1 bit. So if you see, they're same at this bit. They are same at this bit. But they're differentiating, they're different in this particular bit. And that is the reason you got a 1. Because same bits will always give you 0. Same bits will always give you 0. But there's one different bit, which is here. So in 4, you just have to find one different bit. That is what you have to do. So in this case, probably I will say the second bit. The second bit is the different bit. You can just find any of them. If it's a bigger number, there will be multiple different bits. Over here, we just have one, and that is enough. And there will always be one because both of the numbers are different. They are bound to be different at 1 bit. So you just have to find that 1 bit. And in this case, I'll probably take the rightmost. That's an easier thing to do. So I'll take the rightmost bit. So what I've done is, I've taken the rightmost differentiating bit, which is the second one. And probably I can write the bit number as 2. Done. I know the differentiating bit. Let's omit everything. Let's try to focus on the approach. So I know the differentiating bit is 2. Over here, what do we have? We have numbers like 4, 3, 6, 2, 1, 1. Correct? And we also have numbers like 1, 2, 3, 4, 5, 6, which we took. We took this entire number in the, like all the elements in the array, and we took all the elements from 1 to n. Can I say one thing for sure? The second bit position, it will either be 0 or it will either be 1. Like that bit position can either have a 0 bit or it can either have a 2 bit, right? And over here, if I try to count, 1 is happening to be 3 times. Please focus. 1 is happening to be 3 times. And 5 happens to be 1 time. Carefully observe. 1 happens to be 3. 5 happens to be once. All the other numbers happens to be twice. All the other numbers happens to be twice. All the other numbers happen to be twice. So I know one thing for sure. Someone like the repeating number is thrice. The missing number is once, which is odd. Let's try to now solve the problem. So if I take 4, can I say, if I try to write down 4, that is how it is. The 4 will be looking like this in bit. and the second bit is 1. So 4 will be a part of the bit where we have 1, okay. Then if I try to take 3, 3 will be written as probably 1, 1, yeah. So the second bit is 0. So 3 will be a part of the guys who are with 0, okay. Then we have 6. What is with 6? What's the value of 6? 1, 1, 0. So it's basically 1. So 6 will be a part of this. Next, 2. What's 2? 0, 1, 0. So it's a part of the 0. Then we have 1. And 1 is 0, 0, 1. It's a part of 0. Then we have another 1. It's again part of this. Then we have another 1. It's a part of this. Then we have 2. And 2 is nothing but this. So it's on this part. Then we have 3. And it will always be a part of this. Then we have 4. It will always be a part of this. Then we have 5. And if you carefully observe, 5 is 1, 0, 1. And it has 1. So 5 will be a part of this. So this is the bit number. And these are the numbers which are part of. Next we have 6. What is 6? 1, 1, 0. So 6 will be a part of this. Done. So what I've done is, I probably have figured out which numbers are part of the 0 culture, 0 bit, and which numbers are part of 1 bit. Something I know for sure is, all the numbers appear twice, or rather even number of times. 4 appears twice, 6 appears twice. 1, which is x, the repeating number, happens to be thrice, which is odd, and y happens to be once, which is again odd. All the numbers are happening even, and x appears to be odd, and y appears to be odd as well. So if you remember, x was 1, y was 5. And if I again just take you slightly back, 1 was 0, 0, 1. 5 was 1, 0, 1. When you XOR, you got 0, 0, and you got 1. This bit was differentiating. So that is the reason. Why was it differentiating? Because at 1, you had 0. And that's why 1 is a part of the 0 club. And at 5, you had 1. That's why 5 is the part of the 1 club. All the other numbers are appearing even types. So if 3 is a part of 0 club, the other 3 will also be the part of the 0 club. If 1 is a part of the 0 club, all the ones will be a part of the 0 club. If there's a 2, so if there's 1, 2, which is a part of 0 club, the other 2 will also be. If there's a 6, the other 6 will also be a part of the 1 club. If there's a 4, the other 4 will always be. So, since I know one thing, all other numbers are even times. If I XOR all the numbers, if I XOR down all the numbers, I know one thing for sure. All numbers are even. So 3 will cut off with 3. 2 will cut off with 2. The 1 will cut off with 1. And there will be 1 left. Amazing. Over here, all numbers are even. 4 will cut off with 4. 6 will cut off with 6. 5. Amazing. So I know there are numbers like there's only one guy left, one who is a part of the 0 club, which is part of the 0 club. There's one guy which is 5, which is part of the 1 club. And these are bound to be the repeating and missing numbers. But I'm not sure either 1 is the repeating or 5 is the missing. I am not sure. But I'm sure that 1 and 5 are my answers. I just have to figure out which is x and which is y. But I am sure 1 and 5 are my answers. And why am I sure? Why am I sure? I'll repeat. Because all numbers appear even types. So when you if you try to put them into 0 and 1 clubs, all the numbers like 4, there are 2 4s. Either the 2 4s will be in the 0 club or it will be in the 1 club. There are 2 3s. Either it will be in the 0 club, either it will be in the 1 club. There are 2 6. Either in the 0, either in the 1. So at the end, when you take a XOR of everything, only the odd guys will remain. And that's why they survive till the end. And that is why I try to differentiate on the differentiating bit. That is my funda. So if I have to go through the algorithm again, what do I do at first? I go through all the numbers in the array. So it's basically all the numbers in the array XORed with till n. And probably this will give me a number. What's the next step? Find a differentiating bit. Find differentiating bit. That's what you have to do. Find a differentiating bit in number. So basically, what is the meaning of differentiating bit? If you see over here, the differentiating bit will always provide you 1. Same bits will give you 0. Same bits will give you 0. First one you have to find. First one from the right. First one from the right is what you have to find, okay? What's the third thing you have to do? Once you know the first one, once you know the number, just put them into two parts. First part can be the 0 part, second part can be 1. Once you have this, you just have to figure out is 1 the repeating number. Now to figure out, take 1, go through the array. Oh, it happens to be twice. 1 happens to be twice, so I cross-check. On cross-checking, I know 1 is my x and y is my 5. If 1 was not appearing twice, 1 would have been my y and the other one would have been my x. Just have a cross-check by doing a simple iteration. Very simple. Put them into 2 parts and XOR. And you'll get the 2 numbers. Quite simple. I'll code it. It's very, very simple. Don't worry about that. So let us quickly code up this optimal solution. First, I'll be figuring out the size of the array. What is the next thing? If you remember, what we did was we went through the entire array and then we took all the numbers from 1 to n and we did a XOR. So let's go through the entire array. And this is how you can iterate. Let's take a XOR variable which will keep the XOR. And I know I have to XOR all the elements in the array. So XOR equal to XOR of array of I. So this will make sure that I do XOR of all of these numbers. Let's say I have to do a XOR of all the n numbers. And the looping is from I0. So if I do XOR of I plus 1, will it do it? First time I is 0, so 1 will be solved. Next time I is 1, so 2 will be solved. And eventually everything will be solved. So eventually everything will be XORed and stored into XR. So if you remember over here, XR was this value. If I just erase it, on XORing, XR will come up as 100, which is 4. So in 4, you have to find the bit number. You have to find this particular bit number, right? And what is this bit number? This is the second index. How do you find it out? Quite simple in bit manipulation. What you can do is you have 1, 0, 0. So you start with the 0th bit and you check if the 0th bit is set or not. That is not. Then you go to the first bit. Is the first bit set? No. Then you go to the second bit. Is the second bit set? Yes. So basically what you'll do is, probably I'll take bit number equal to 0 and I'll keep on going till it is not set. And how do you check it is set or not? So if you have a 1, 0, 0 and if you put a 1 here and then you say and it. So what will happen is you'll get 0, 0, 0. Why? Because AND only works per 1 and 1. So you'll get 0 and 1 as 0. So you got a 0, right? But if you take the same thing as 1, 0, 0 and you put a 1 over here and you take 0, 0, you'll get 0, 0 and you'll get 1. So you'll get a number. For this, if you put a 1 over here and you put everything 0, you'll again get 0, 0, 0. So beneath every bit index, put a 1. Beneath every bit index, put a 1. Beneath every bit index, put a 1. And anything that gives a number apart from 0 will be the bit index which is set. In this case, it is 1 because 4 was nothing but 1, 0, 0. So the second bit index was set. So the second bit index was set. Quite simple. And how do you put a 0? It's very simple. If you do 1 left shift of bit index, 1 left shift of bit index or bit number, that will do it. So what does this mean? If you say 1 left shift of 0 times, if you say 1 left shift of 0 times, it will stay as 1. If you say 1 left shift of 1 times, 1 will be this one will be left shifted by 1 and it will come over here. Next, if you say 1 left shift of 2 times, this 1 will be left shifted by 2 and it will come over here. I found 1, 0, 0. So what you will do is you will say if you know the number is XR and of 1 left shift of bit number. And if that is non-zero, so you can just do it. If this value comes out to be non-zero, fine, this is my bit number and I can break. Or else, let's move to the next bit number and find it. So first what will happen? Bit number is 0. So this thing will happen. Where you'll put a 1 here and you'll try to do an and it'll give you a 0. Next, it'll move here and it will again give 0. Next, it will move here and again give this number. Done. So this will make sure that I get the bit number. So I have the bit number. What will be the value of bit number if I ask you? The bit number will be 2. Let's quickly erase this so that you understand everything perfectly. So what is the next step? You already have the bit number 2. Now you have to go through these numbers and segregate them. So 4 was, if you remember, on the part of this 1. Why? Because 4 is 100 and the bit number is 2. So the second index is set. So 4 was a part of this one. So probably I'll keep this portion and this portion as 2 variables. Let's keep this as 0 and let's keep this as 1. So I'll keep 2 variables down. Someone who is a part of the 0. So initially it's no one. And someone who is a part of 1. Which is 0, no one. Next, let's go across these numbers. First I'll go across 4. So if I go across 4, how can I go? Like this. If I go through this, we'll get through 4. Now for 4, it's 100. I have to check if the second bit is 1 or not. If the second bit is 1 or not, how will I do? I'll put a 1 here, which means I'll say if array of I and of 1 left shift of bit number. If I say this, what will happen is there will be a 1 here and it will be 0. Do an add 0, 0, 1 and it is non-zero. And it is non-zero. So what you can say is if this comes out to be, just a second. Yeah. If this comes out to be non-zero, that means it's a part of 1. It's a part of 1. This means it's a part of 1. Very simple. Part of 1 club. Or else, it's a part of the 0th club. Again, quite simple. What will be the next thing? Let's see. If this 4, as we see, is a part of the 1 club, so it will go to the 1 club. And what did we do? Like, do we need to store the numbers? Do we need to store the numbers like 4, 6? No. What did we do at the end? We just did a XOR of 4, 6, 4. Whatever numbers we got, we just kept on doing a XOR. And 4 got cancelled with 4, 6 got cancelled with 6. The numbers in itself get cancelled according to maths. So it's not that it will wait for a 4. It will get cancelled. That's how bit manipulation works. So eventually 5 was left. So what you'll do is, instead of storing, just keep XORing whenever you get it 1 equal to 1, XOR the number. Or else 0, it will be a part of the 0 club. 0 XOR the number. Perfect. This is done for the entire array. What's the next thing? To do for all the numbers. Please go ahead and do for all the numbers. So you can do it on that loop as well, or you can just run another loop as well. That's your choice. And you can just write the same thing, part of the 0 club or part of the 1 club. And over here, instead of A of I, it will be I, because that's the number. Perfect. And over here, you'll do an I. Done. So once you have done this, you will have the 1 ready. So once you have gone through this entire thing and this entire thing, you will have the value of 0 to be 1. Why? Because everything will get cancelled and the value of 1 to be 5. Right? So you have the 0 and 1. You just need to confirm. So what I'll say is count equal to 0. I'll go across the entire array and I'll be like, if A of I is equal to 1 or rather 0, counter plus plus. So if at the end of the day, counter is 2, which means 0 was my repeating number. So 0 and the other one will be my missing number, or else it's the opposite. Quite simple. Don't store numbers in a bucket. Because there's no point in storing everything. Because at the end of the day, you are trying to XOR everything. So just do a XOR when you collect numbers. Why do you want to just store it and do it in the future? Just do it right away. Right? This is how it will be. Quite simple. So I can go ahead and run it off. And this will be running absolutely fine. Yes, it does. Now, do I need to go, like I did this because I wanted to explain you bit manipulation slightly. I did this to find the bit number. And then I did this to generate that number. So what we did was, I can trim that as well. What I did was, I knew the XOR was 4, right? And which is 100, correct? And what we did was, we figured out this was the second bit. and every time we did like one left shift of second. So in order to generate that number, because we were not doing anything, we were just taking the 6110 and we are doing a solve with 100 to check if this bit is set or not. Every time we were generating this number, to check if the second bit is set or not. So instead of doing all of these things, easy bit manipulation trick, I think that number can be written as, I think it can be written as XR, and it will be AND of not of XR minus 1. Yeah, that's what it can be written as. Again, I'll be teaching that in bit manipulation, and you can just convert this into number. If you know bit manipulation, you'll understand it. And if I go ahead and run this, this will be running. What happened? Bit number was not declared. Oh, sorry, my bad. Okay, you have to just make sure that it's everywhere. Cool. Done. So if you run this, this will also be running fine. I did it because I know some people will come up in the comment section and say, hey, why are you running it? Do it like this. This is how you can easily generate the number with a 1 at the differentiating bit. Very simple. So this is how easily you can do it. And that will replace all those steps. But those steps were super intuitive. So I'll probably suggest you to do those steps in the interview because that will be much more helpful. Let's go back and compute the time complexity. Big O of n, big O of n, big O of n, and big O of n. Near about big O of 4n. This could have been clubbed over here. So big O of n, like we can say near about big O of n is the time complexity. Near about big O of n is the time complexity, and the space complexity is big O of 1 because we're just using variables. We're not using any buckets, just variables. This is the time complexity and the space complexity. I know this was slightly tough, but if you have understood this, your level is right up there with the best and you're doing really, really good. So let's go back to the sheet and let's mark it as complete. So this one done as well. I hope you've understood all the 4 approaches. Just in case you did, please do consider giving us that like because it won't cost you anything, but it will highly motivate me to make these kind of content. And if you're new to our channel, what are you waiting for? Hit that subscribe button. If you haven't followed me on Instagram, Twitter, LinkedIn, all the links are in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye. Take care.
Whenever your heart is broken.